I want us to look at this question 9 of this paper, two question paper. So now on this one, this is the simplified diagram below represent an electrolytic cell that is used to demonstrate the electrolysis of a concentrated sodium chloride solution. They say X and Y are the carbon electrodes, and then we have the concentrated sodium chloride solution. So I'll definitely explain everything as I answer these questions, okay? The first question says that define the term electrolysis. What is an electrolysis? So electrolysis, we know that it's a process in which electrical energy is used to force a chemical reaction to occur. Okay, so the reaction will not happen by itself. That's what we call an electrolytic. Therefore, if the reaction cannot happen by itself, we say electrical energy must be supplied by the battery. The key words in your definition is electrical energy, non-spontaneous reaction. But you can also define this using your exam guideline. It's up to you. So this is the use of electrical energy to drive a non-spontaneous Okay, so I hope you're also checking your exam guideline on your site and see what definition they have for you, okay? Chemical reaction. Okay, so let's quickly go and work on 9.2. Write down the reduction half cell for this cell. Reduction half cell. So let's quickly go and work on that. They want us to write down the reduction half cell. Okay, so to write down the reaction half cell for this cell, first thing first, to answer this 9.2, I need you to identify the cathode. Right. Why the cathode? Because the reason I want to identify the cathode, if you still remember on our previous question, we talked about the cathode, it's where the reduction occurs. So if you can manage to identify which one is the cathode, then you are good to go. So you identify the cathode, and how are you going to do that? Let me give you steps. First thing, we know that in electrolytic cell, so we say that in electrolytic cell, we have the cathode and the anode. The cathode and the anode. Right, so these two guys, the cathode, it's where we have the negative electrode. So the cathode, this will be the negative electrode. Okay, and this one is where we have the positive electrode. That's what you need to understand first for you to master this one, this question. Okay, so now when I look at this, I can see that the battery shows X that is connected to the positive terminal. Remember, if I have something like this, the taller one is the positive and the smaller one, it will be the negative. So X is connected to the positive terminal and Y is connected to the negative terminal. That's what we see. Therefore, we can conclude and say that the Y is the cathode. So now you know that why are we saying that the Y is the cathode. Remember, the cathode, we have the negative electrode. Then we look at this, which one is the positive, which one is the negative. Then we can see that the cathode is the Y. Okay, I hope that you are having fun so far, because I think everything now starts to make sense now. So determine which particle gains electrons. So now remember, reduction is a gain of electrons. So you need to determine. So that was step one. You identify the cathode. After identifying the cathode, on the second step, which is step two. So on the second step, you need to determine which particles which particles gain electron. Okay, so when I look at this, I need to look at the positive spices. I'm sorry. So I'm going to look at the positive spaces that are present. Okay, I'm sorry if I'm saying this wrong. That are present. Né? Okay. Let's look at this. We have the gas. Let me go back to the statement of this question. The statement said the simplified diagram represents an electrolytic cell that is used to demonstrate the electrolysis of the concentrating sodium chloride. So the positive species present, it will be the sodium. So we know that the positive one is the sodium. It has a positive charge, right? And also water. It's also the water is present, right? And also water. So look at this. Water, this guy here, the water is reduced more easily than sodium ions, okay? So water, the H2O is reduced more easily than what? It reduced more easily than the sodium ions. Okay, so then when you understand this, you'll be able to write the reduction reaction. So when you write the reduction reaction, we said that water is the one that is reduced more easily than the sodium ion. So this tells you that I'm going to have, I can definitely go to maybe my, where is that? I'm looking for, okay, let me look for water. I'm not sure if you guys can see water on your side. H2O, 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 where are you? Come on, H2O, where are you? Okay, we have lots and lots of H2O. So I don't want the one that has, okay, so this is what I'm looking for. This is my, this will be my, the reduction reaction, okay? Because we said water is reduced more easily than sodium. So I'm going to take that reaction. So that will be my reduction half. That will be my reduction reaction. Let's quickly go and write that. So the answer for this is going to be 2H2O, which is in liquid state. Then we have 2E, H2, hydrogen gas is formed, plus 2 of OH minus in aqua solution. Okay, let me see what do we have on the next question. Next question, what is the direction of the electron flow in the external circuit? Choose from X to Y or Y to X. Guys, I know that this is 1 mark, but I don't want you to do guesswork, okay? So remember that we said that electrons understand or you can recall the rule of electrons. So the electrons always move from what? From anode to cathode. Okay, so to answer this 9.3, electrons, they always move from cathode they always move from, let me just write it down here, from the anode then all the way to the cathode. Right, so you identify the electrons and then we need to know which one is the anode and which one is the cathode. So the anode, we said they, when I look at this, I need to understand which one is the anode between X and Y, which one is the cathode. Okay, so we said that the cathode is the negative electron. So this is the cathode, the Y is the cathode, and the X is the positive electron. So this will be the anode. And we are saying that they move from, the electrons move from anode, which is X, all the way to the cathode, which is Y. So the correct answer is X to Y. That was easy, né? 9.4. Calculate the number of electrons transferred through the external circuit when 3 centimeter cube gas is collected at electron X. Take the molar gas volume as 24 decimeter cube. Okay, I'm going to work on this one, okay? I'm going to definitely work on this one. Let me take this question. Let's put it on the other side, then we'll start working on it. Okay, in fact, I'll just write the given. Make sure that you read the statement to understand what is going on. Calculate the number of electrons transferred through the external circuit when the 300 centimeter gas is collected at the electrode X. Okay. Right. So what I'm going to do, I'm going to work on that. I'll first start with what I'm given, and then I'll take it from there. Okay. So let's first identify the gas produced. That is something that you can start with. So I'm going to first identify the gas that is produced at X. Okay. So we know that we said, if you still remember, X is the anode. And then at the anode, what is going on at the anode? Okay, so I'm just going to look at the anode. This is my anode. This is my cathode. So at the anode, look at this. I know that inside that solution, I have something very special there. Inside the solution, we have concentrated sodium chloride solution. So let me explain what will happen at the anode. At the anode, we know that it's where oxidation takes place. Né? So oxidation, that's, am I right when I say oxidation? Let me quickly because I don't want to confuse myself, let me just go and revise this very quick from what we did previously. We said that cathode electron where reduction occurs, and we said reduction is gain of electrons. Yes, so oxidation is loss of electrons. Okay, let me go back to this. So now to answer this question, when I look at the anode, I know that I have just go to the formula sheet. Where's that formula sheet? Let's look for the chlorine, because we have the concentrated sodium chloride. Let me look at the chlorine there. And this is what I'm looking for, ladies and gents. So now, this is when it's at the anode, what happens? There's a gain or loss of electron. We need to write it the way, in the correct way. So at the anode, we said that this is oxidation, loss of electrons. We said whenever you lose electrons, the E should be on the reactant. So this will be 2Cl minus. Then into aqua solution, it goes and turns into Cl2 in gas state plus 2E minus. So this is how we should write this, because it's at the anode, loss of electrons. So I'll just quickly write this down and say at the anode. You'll see what I'm trying to do here. So my reaction is 2Cl minus in aqua solution. This gives us Cl2 in gas state, and then plus 2E. Right. Then, therefore, this tells you that the gas is chlorine, right? Look at this. The gas is chlorine. I think you can see that the gas is chlorine. The gas is chlorine. I think you understand how I got to that. Let's just go back a little. We said first thing first, to answer this 9.4. First thing first, we're going to identify the gas that is produced at X. And we said at X is anode. And look at this. We said what they said on the statement that we have the concentrated sodium chloride solution. Then I just go there and look for the chlorine, and then I write the reaction for that. Okay, then I'll keep moving. The next step I need to convert. The next step I need to convert from centimeter cube to decimeter cube. Remember, when I look at this, I'm given the 300 centimeter cube. I need to put that in decimeter cube. So next step, you're going to convert from centimeter cube to decimeter cube. And then how do we do that? So you are given 300 centimeter cube. Then you're going to divide that by 1,000, because we know that 1 centimeter cube, not one, but 1,000 centimeter cube, it will be equal to 1 decimeter cube. So we can just divide that 300 by 1,000, and this will give us 0.300 decimeter cube. So that's our volume. Right. So now that when you have the volume, this is step 1. We identify the gas that is produced at X. Step 2, we convert it from centimeter to decimeter. Now, step number 3, I want you to calculate the moles of the chlorine gas that is produced. Okay. So we need to calculate the moles of chlorine gas. Okay, because if you still remember, the question said they want us to calculate the number of electrons transferred through the external circuit, right? So first find the moles of the chlorine gas, and which formula you're going to use. By looking at that 24 decimeter cube that was given as the molar volume gas, if I have V, I know that I'm given the Vm. So this is equals to what? This is equal to N. That is the formula. That will be the best formula to use. Okay. So if this is the formula that we're going to use, you just have to substitute your volume and your Vm to find the number of moles. Right. So this will be N. It's equals to V over Vm. Do the substitution. The volume is the one that we just converted as 0.300. Everything divided by the Vm that is given as 24. Punch that on the calculator. Let's see what we get from that. We're going to take the 0.3 divided by 24, and this gives me an answer of 0.125 moles. So the number of moles for the chlorine gas, therefore the number of moles it equals to, let me write it like this so that we don't forget, and I'll also highlight that next. So the number of moles of Cl2, it's equal to 0.0125 mole. Let me quickly highlight that so I can show that I'm going to use this answer in future. Just follow my steps, you'll see what is going on here. Okay, so this is the number of moles of that chlorine, and we'll definitely need that. Okay, so now what's next? Therefore, you use the mole ratio. This will be in step 4. You're going to, not step 3, but step 4. You're going to use the mole ratio. Step 4. Use the mole ratio. We're going to use this mole ratio to calculate the number of moles or the number of electrons. Let me just say electrons, right? So if I have, look at this, if I have 2 Cl minus, and we said this forms Cl2 plus 2 electrons. Okay, so what will be the ratio in this? According to your own understanding, what will be the ratio? So the ratio here, it will be 2 of, okay, let me, instead of saying 2 of that, let me say I have 1 chlorine, right, which is this part, is 2 electrons. Okay, so to find the number of electrons for that chlorine, therefore I can say, instead of saying the number of electrons for chlorine, I can say therefore I know that the chlorine, I already have the number of moles for that chlorine, which is 0.0125. So I need to take this 0.0125. I need to multiply that by what? By the 2. So you multiply that by 2 according to mole ratio. This gives us what? This will give us 0.0125 times 2. Let me quickly put that on a calculator and see what is that equals to. 0.0125 multiplied by 2, and this is 0.025. So this will be 0.025. 0.025 what? Electrons. You understand? Okay, so I hope you get that part. So I'm going to use the information that I have now to go to step 5, where I'll be calculating the number of electrons. Okay, so on number 5, I'm going to calculate number of electrons. Okay, so to calculate the number of electrons, the formula, it goes like this. N is equal to small n over Na. And this Na, they'll definitely give it to you on the formula sheet. Let's quickly go and look for that Na from this formula sheet here. What is Na? It's a constant of 6.02 times 10 to the power 23. So this is 6.02 times 10 to the power 23. So I'm just going to substitute. I know the number of moles we just calculated to be 0.025. Then multiply that by, this will give me the number of electrons when I multiply this with that 6.02 times 10 to the power 23. Right, so this, what is that equals to? We just have to multiply these two numbers and see what we get. The answer that you get, it will be the number of electrons that are transferred in the external circuit. So 0.025 multiplied by 6.02 times 10 to the power 23. So I'm just going to try put this inside the bracket and this inside the bracket and see what we get. 1.505. If we round it off, it's 1.51 times 10 to the power 22. And that's your final answer. 1.51 times 10 to the power 22. If you don't understand this solution, I'm not sure how many solutions they give you in a memo, but this is the best approach, trust me. First thing first, you identify the gas that is produced at X, okay? You identify the gas that is produced at X because the question said the gas collected at electron X. So the gas that is produced at X is there, we said is chlorine. And then, so since the gas that is produced at X is chlorine, then we convert the centimeter to decimeter, then we calculate the number of moles of that gas. When you have the number of moles of that gas, you use the mole ratio to find the number of moles so that you can be able to calculate the number of electrons. Right, so before I say that's it for this question, I want to give you a quick revision. Okay, so remember in galvanic cell, let me just quickly give you this, guys. Remember, this is just for revision since you'll be going in for your exam. So for galvanic cell, we say that these galvanic cells, they produce electricity, and the anode, it's where the oxidation occurs. And then we have the cathode, it's where the reduction occurs. Okay, so, and then the electrons, they flow from anode to cathode. That's also important to understand. And then in electrolytic, I'm just gonna write the electrolytic with the different electrolytic cell. So instead of electricity, this one, the galvanic they produce, then the electrolytics they will use. They uses that electricity. And then the anode, we said that the anode is positive, the cathode it's negative. Right. And then the electrons still flow from the cathode, the electrons still flow from the anode to the cathode in both galvanic and electrolytic cell. Right, then now let me give you the most important memory trick. So we have the oil rich. This tells you that oxidation is loss of electrons, reduction is gain of electrons, and then we have the red cat, which means that reduction happens at the cathode, and then we have the what is this? An oxidation at anodes, and electrons always move from anode to cathode. I think, guys, you already understand this concept, and that's it for this one. This is how you answer a question based on for electrolytic cells. That's it for this one.